Yes, students, welcome to the last theoretical lecture of chapter 3, which is linear regression. In this lecture, students, we are going to discuss in detail our last topic, which is coefficient of determination. Students, coefficient of determination is denoted by capital R square. First of all, the first point, what is the purpose of studying coefficient of determination? Now students, have you ever thought that whatever estimates we are obtaining from regression line, are these estimates reliable or not? Or conversely, if I want to check the reliability of this estimate, students, how can I check? Then the answer to this question is that reliability of estimates obtained from regression line can be verified by finding coefficient of determination. So your first VSQ from this topic, what is the main purpose of studying or finding coefficient of determination, students? It helps us to check the reliability of estimates, students, obtained from the regression line. Now students, what is the definition? What is the formal definition of coefficient of determination? In exam, you can be asked, define coefficient of determination. So students, understand this very perfectly. Suppose the regression line of y on x is y cap is equal to a plus bx. We find correlation coefficient. We find correlation coefficient between exact value of y and estimated value of y, which is r between y and y cap, and square it. Then students, whatever answer I get, that is coefficient of determination, which is denoted by capital R square. So if I want to define the coefficient of determination based on this formula, pay attention how to define. Square of correlation coefficient between exact value of y and estimated value of y from regression line is called coefficient of determination, students, denoted by capital R square. Clear? So again, if I want to define coefficient of determination, it is the square of correlation coefficient between exact and estimated values of dependent variable y. Now students, y cap is a plus bx, and if I simplify, you know that correlation coefficient r is independent of change of origin and scale. So the formula of capital R square will be same as only simple R square. So in the sum, students, if you are told to find coefficient of determination, we will simply find correlation coefficient R as per our chapter 2 and square it. The answer will lead us to coefficient of determination. So in simple means, the formula of coefficient of determination is simply R square, where R is nothing but correlation coefficient between, students, variables x and y. Now if coefficient of determination has to deal with correlation coefficient, now you know range of correlation coefficient is from -1 to +1, but if I square -1 or +1, answer is 1. So the maximum value of capital R square, which is coefficient of determination, is 1. You know R can be 0 also. R is equal to 0 indicates lack of linear correlation. In that case, R square will be 0. So coefficient of determination is 0. So students, I have formulated certain basic concepts for this topic, and your first MCQ or VSQ asked in board examination, students, what is the range of coefficient of determination capital R square? The answer is closed interval 0 to 1. Minimum value of capital R square is 0 and maximum value of capital R square is, students, 1. So try to formulate the questions from this topic, students, you will be easily understand. Question number 1. What is the purpose to find coefficient of determination, that is capital R square? Answer is, the coefficient of determination helps us to check whether the estimates obtained from regression line are reliable or not. Second, define coefficient of determination, the square of correlation coefficient between exact value of dependent variable y and estimated value of dependent variable y, which are yk, is called coefficient of determination, students, denoted by capital R square. So range of capital R square is closed interval 0 to 1. So minimum value is 0. So when, students, the value of capital R square is close to 0, we will say the assumption of linearity of regression invalid. What does this line mean? Assumption of linearity of regression invalid means this regression line is not reliable, and hence the estimates, students, obtained from regression line are not reliable. So capital R square close to 0, assumption of linearity of regression invalid, and hence estimates are not reliable. On the other hand, if the value of capital R square is close to 1, assumption of linearity of regression valid, it means this regression line is valid, and hence, students, the estimates which are obtained from regression line are 100% valid. Now, one more point which is not discussed in our textbook. What if capital R square is 0.5? In that case, it is neither close to 0, it is neither close to 1. We will write in that case that more statistical tests are required to check the assumption of linearity of regression. This is not given in new textbook, it was given in old textbook. So it is a possibility, students, where capital R square can be 0.5. Clear? All of you understood? So capital R square has 3 interpretations: close to 0, estimates are not reliable, assumption of linearity not valid, close to 1, you can say assumption of linearity of regression valid, estimates are reliable. And if it is 0.5, more statistical test and analysis is required to check the assumption of linearity of regression, students. So very, very important. Now, students, based on the value of capital R square, we have one MCQ, and that MCQ is like this, that if R is equal to 0.9, then what is the value of coefficient of determination if R is 0.9, students? Small r. Let me erase this and write. Suppose, students, correlation coefficient R is 0.9. Then coefficient of determination will be square of 0.9, students, and that is how much? 0.81. So our coefficient of determination is 0.81, and if I write it as percentage, it is 81%. So it can be said that out of total variation of variable y, explanation of 81% of variation can be obtained from regression line. Students, pay attention. What is the MCQ? Suppose correlation coefficient R is 0.9. So coefficient of determination will be square of 0.9, which is 0.81. And 0.81, if I write in percentage, this is nothing but 81%. So 81% of variation of y is obtained from regression line. Or I can say 81% of the variation in the value of y can be explained with the help of the regression line. and 100 minus 81, which is 19%, that much you can say variation is not obtained or explained from the regression line. In your textbook on page 138, we have a paragraph I am reading. How much variation in the dependent variable y can be explained by regression line? Now for that they have given that if r is equal to 0.9, then the coefficient of determination is 0.81, percentage is 81%. So out of total variation in variable y, 81% of variation can be obtained from regression line. Suppose r is 0.7, then r square will be 0.49. So we can say 49% of variation out of total variation can be obtained or explained from regression line, and not explained variation in terms of percentage is 100 minus 49 students, which is 51. So based on this value, we can say that this much percent of variation in the value of dependent variable y can be explained or obtained from the regression line. Now students, pay attention. Our pending MCQs from section A, I think we can easily conclude. Now students, our pending MCQs from section A and pending VSQs, if at all we have, from B and C can be easily done students. So now we are summarizing students one section. I think last time we did MCQs that the regression line always passes through the point x bar and y bar. Now students, I think we were pending with two MCQs, and those MCQs are MCQ 10 and 15. Now, what is coefficient of determination in the study of regression for two variables? Students, coefficient of determination is nothing but square of correlation coefficient. So the correct option is B. We have written the formula also. Capital R square is coefficient of determination. The formula to find coefficient of determination is simply square of correlation coefficient between variables x and y. So students, MCQ 10, the correct option is B. Now if R is equal to 0.8, how much part of variation in the dependent variable can be explained by the regression model means line? So if R is 0.8, R square is 0.8 square, which is 0.64, and that is 64%. So 64% of the total variation in the value of y can be obtained from the regression line. So here the correct option is B. So students, this completes our section A. Now I think in section B we are left with no MCQ, VSQ, sorry students, all VSQ we have done students. Now in section C, I think we are left with, or we have not done, I think, question 6. If the regression coefficient of the line of y on x is 0.6 and the standard deviation of x and y are 5 and 3, then find coefficient of determination students. To find coefficient of determination, we need correlation coefficient R. Now here students, they have not given the value of correlation coefficient R, but students, instead of that they have given B and they have given Sx and Sy. Now all of you know this formula. Section B students, we are doing sum number 6. Byx is equal to R into Sy upon Sx. They have given the regression coefficient, means B is 0.6, R unknown. Standard deviation of x and y are 5 and 3. So this is 3 and this is 5. Sx is 5 and Sy is 3. So R will be how much? 0.6 into 5 divided by 3. So this will be 6 by 10. So 0.2 into 5. Isn't it students? Now 0.2 is 2 by 10 into 5. So the answer is 1. Now if correlation coefficient R is 1, then students, coefficient of determination capital R square is equal to small r square is equal to 1 square. So that will be also 1. So what we did in this sum, students, in this sum we were not given R. So whenever students we are told to find coefficient of determination, our prime concern is to find correlation coefficient R. If correlation coefficient R is directly given, squaring it, we get coefficient of determination. So I think, students, this completes our sections A, B and C in total. Students, we have done all the sums of section A, B and C. So let me start giving you the homework. So your prime concern is to write each and every question of section A, B and C again and complete it, students. Now we come to section D. I think in section D I have explained the first 4 questions, even question 5, question 6, explain coefficient of determination, that we have already done, students. So in section D, sum number 6, again I am summarizing how much and what you should write. First point, the purpose to study coefficient of determination is to check the reliability of estimates which are obtained from regression line. Definition of coefficient of determination. Suppose the regression line of y on x is y cap is equal to a plus bx. The square of correlation coefficient between exact value of y and estimated value of y, which are y cap, is called the coefficient of determination, denoted by capital R square. The formula to find coefficient of determination is capital R square is equal to small r square. The range of coefficient of determination is from 0 to 1, 0 and 1 included. If the value of capital R square is close to 0, assumption of linearity of regression invalid, means regression line not valid, and hence the estimates are not reliable. If the value of capital R square is close to 1, the assumption of linearity of regression valid, means regression line valid, and the estimates obtained from regression line are reliable. And even I can say that if the value of capital R square is close to 0.5, more statistical tests and analysis are required to check the assumption of linearity of regression. So this is what you have to write, students, in the topic or in the answer of explain coefficient of determination. Now, students, answer 7. What precautions or state precautions which are necessary while using the regression? This topic I have not done because this topic was connected to coefficient of determination. Now, students, we can easily do this topic. State the precautions while using regression. This is given on page number 148. Now, students, what precautions we should consider while using regression? Now, all of you know regression is a functional rule or a mathematical equation between independent variable x and dependent variable y. Regression as a concept is useful, students, in various you can say branches of mathematics, in commerce, even you can say in arts, etc., depending upon the requirement. So regression is a topic which is broadly, widely used in different field in day-to-day life. Now, whatever estimates we have obtained from regression line must be cross-verified by finding coefficient of determination, students. The reliability of estimates can be verified by finding coefficient of determination capital R square. So one should use the estimates obtained from regression line only after ascertaining it with finding coefficient of determination. So you have obtained estimates from regression line, but you should pause for a minute or pause for a while. First find a coefficient of determination, and if it is close to 1, your estimates are reliable, and hence you are free to use the estimates obtained from regression line. So in general, the first point, before using the estimates obtained from regression line, one must verify first by finding the coefficient of determination. If your answer of coefficient of determination is close to 1, your estimates are reliable, you can use it. But if your value of capital R square is close to 0, the assumption of linearity of regression not valid, estimates are not reliable. Now, be careful. The another precaution, students, check. I am reading the precautions given in means textbook. The exact precautions are: reliability of estimates can be verified by coefficient of determination. So we should use the estimates only after ascertaining the linearity of regression by coefficient of determination. Now, pay attention, students. The second precaution. First of all, I am just reading it from textbook so that you try to understand. Another point which is necessary to be kept in mind is that while using regression analysis is the regression relation obtained by scatter diagram or by the method of least square should not be used for the values which are very far from the given values of independent variable. Students, once again, the regression relation obtained by scatter diagram or by the method of least square should not be used for the values which are very far from the given values of independent variable. It means what? Suppose the values of x are given within the range of say 40 to 70. The values of independent variable x, students, are given, you can say, within the range of 40 to 70. Now you are told to find the estimate of y when x is equal to 190. Now 190 is very far from the range of 40 to 70. So this regression model, students, will not give you the perfect estimates. Or conversely, your value of x was say minus 80. Now minus 80 is also very far from 40 to 70. In that case also, students, you should not use the regression model or regression line which we have obtained by the method of least square. So the second point tells us that you can use this regression line provided the value for which you are going to estimate y, the value of x for which you are going to estimate y is not very far from the given values. So the value for which you are estimating should not be very far from the given values of x. If that is the case, then the regression line which you have obtained may not be fruitful, and hence the estimates of y which you obtain from regression line may not be reliable. So in short, two precautions only, students. First precaution, before using the estimates obtained from regression line, we should verify it by finding coefficient of determination. And second, whatever regression line we have obtained either by scatter diagram method or by the method of least square should not be used to estimate values of y for x where this x are far from the given values of x. I told you your given values of x are in the range of 40 to 70 and you are told to find estimate of y for x is equal to 180 or minus 80, and that value is very far from the given values. In such a case, your estimates may not be reliable. So students, this completes, I think, all the theories of section D. up to question number 7. Now I think question 8 also we have done. I think question 9 also, students, we have done. Question 10 we have not done of section D, students. That we are doing. Try to understand. Section D, students. Question 10. If the regression line of y on x is y cap is equal to 11 plus 3x. Section D, question 10. Regression line is y cap is equal to 11 plus 3x. A plus bx. A is equal to 11. B is equal to 3. Check, you can easily compare. And the ratio Sx is to Sy is 3:10. Now students, we have the formula Byx is equal to R into Sy upon Sx. B is 3, R is unknown, this becomes 10 by 3. Sx upon Sy is 3 by 10, so Sy upon Sx will be 10 by 3. So R will be 9 by 10. How much? 0.9. So coefficient of determination will be r square, 0.9 square, and that is nothing but 0.81. So we have found out the coefficient of determination, and this value 0.81 is close to 1. So the assumption of linearity of regression valid means this regression line is valid, and hence the estimates obtained from regression line are reliable. That's all, students. So I think this completes our section D also in total. Now in section E, students, we have done question 3, 4 and 5, I remember. And I think in section F we have done question 6. Remaining are long sum, students, which we have not done. So this completes our chapter. Only long sums are remaining, and that too all long sums are done on the same criteria. Students, long sums will not take more than 3 lectures, trust me. The main part was, you can say, to understand the theories of the chapter and to understand the short sums. So this completes our chapter, students. I again repeat, long sums are pending, but you need not worry. If you are very thorough with the short sums and theory, students, long sum is not at all difficult, very, very easy. So we conclude the lecture here. I hope you go through the chapter very thoroughly, go through the lectures again and again till you are very thorough with the concept. Write all the sums of section A, B, C, D once. I repeat, write all the sums of sections A, B, C and D once. We conclude here. Very soon we will meet for the next lecture, students. In the next lecture we are going to start chapter 4, students, which is time series. Next chapter, students, will be our chapter number 4, students, which is time series. Thank you, students. Stay safe, stay home, work hard, don't waste time.